Alright, we're going to take some notes on lesson 7.3 that you can watch in class since I'm not going to be here today. So I'm not playing hooky, I'm just not feeling well. So I'm going to do the video and hopefully you'll be able to watch the notes and not lose a beat when it comes time to getting your homework done. So here is lesson 7.3. I'm going to do 6 problems. And the topic is adding, subtracting, and then multiplying radical binomials. So we're going to add and subtract binomials first. And so if you want to set up your notes like this, if I add and subtract binomials, here's the first problem that I'm going to set up for us to do. Let's say we have 7 times the 4th root of 5, and we're going to add to that 2 times the 3rd root of 5. And I want to add those together. I wish I was there because I can ask you how we would be able to do that, and I'm hoping that some people might say, well, because they're both 5s, we should be able to add them together, but the indexes must be the same. Another thing that we can't do is if it was something like this. Let's say it was 8 radical 2 minus 9 radical 3. Again, this problem we would not be able to do because in order to add or subtract radicals, we have to have radicals be the same. It's the same thing as if I had 8x minus 9y. Couldn't subtract it. The only way that I could is if they were both x's or if they were both y's. So the first problem is really pretty easy. You don't want to try to do something that you really can't do. Let's take a look at number 2. If I have 5 radical 6 and I want to add to that 3 radical 6, now I can go ahead and add them together. It's not radical 12. I'm not adding I'm not adding the radicands. What I'm doing is adding the whole numbers. 5 plus 3 is 8. Radical 6. Oops. 8 radical 6. So we have to be careful whether we can do it or not. It looks fairly easy, but sometimes it looks something like this. Let's say we have the square root of 50 plus 3 times the square root of 32 minus 5 times the square root of 18. Now you might at first be thinking, well, that's an example of one we can't do because the radicals are not the same. But if you simplify the radicals, then you can add them together. So this would be an example of where simplifying radicals allows you to do other things. For example, square root of 50 you could write as the square root of 25 times the square root of 2, which is 5 radical 2. The square root of 32 is the square root of 16 times the square root of 2, which is 4, and 4 times 3 is 12 radical 2. Square root of 18 is like the square root of 9 times the square root of 2, and the square root of 9 is 3, and 5 times 3 is 15 radical 2. So now they are all radical 2's, and now we can add them together. 15 plus 12 is 17. 17 minus 15 is 2 radical 2. So all of that would simplify to 2 radical 2. That is how we add and subtract radicals. What I want to do now is move on to multiplying radical binomials. And so what I'm going to do next is we're going to be multiplying binomials. I'm sure you'll make fun of me for that one. That's okay. Binomials. So it's going to look something like this. Typical problem might be if I take the square root of 2 minus the square root of 3 and I square it. Big mistake that a lot of people will make here is they'll just take the square root of 2 squared and make it 2, the square root of 3 squared and make it 3, 2 minus 3, and they'll think that it's negative 1. But that is not what we're doing here, because the squared part means that we're going to take the square root of 2 minus the square root of 3 times itself. So that means we're going to have to FOIL. So I'm going to take the square root of 2 times the square root of 2, which is 2. The square root of 2 times negative square root of 3 is negative radical 6. If I multiply the radical 3 out, negative radical 3 times radical 2 is another negative radical 6. And negative radical 3 times negative radical 3 is positive 3, because it's a negative times a negative. And then I can simplify this. 2 plus the 3 is 5, and then I have minus 2 radical 6's. So this whole thing simplifies to 5 minus 2 radical 6. Let's take a look at another one. You might recognize this, and hopefully you can name what these are. If I have 5 plus radical 2 times 5 minus radical 2. Again, if I was there, I'd ask, what do we call these two things? And hopefully some of you are already thinking that those two things are conjugates of each other. Remember, a conjugate is the same exact thing, but a plus instead of a minus, or a minus instead of a plus. So if I multiply this out, something interesting happens when you multiply conjugates together. And that is all the radicals disappear. So for example, if I FOIL this, 5 times 5 is 25. 5 times negative radical 2 is negative 5 radical 2. Radical 2 times 5 is positive 5 radical 2. And then positive radical 2 times negative radical 2 is just negative 2. So when I simplify this, I'll have 25 minus 2, which is 23. But then negative 5 radical 2 and positive 5 radical 2 is 0. Sorry, you couldn't see that. So it looked like that. And the answer is just 23. So one of the things that is interesting about that, or that helps us in other things, is that if you want to get rid of a radical, you can multiply it by its conjugate. Here's how that is helpful. Let's say, for example, we have something that looks like this. 3 plus radical 5 over 1 minus radical 5. So in number 6, we can't simplify anything. We can't just cross off the radical 5s because we can only do that if they're factors and we're multiplying. But what we can do is we will have to rationalize the denominator. We can't have a radical sign in the denominator. It's a lot easier if there's just one radical sign. We did that yesterday when we multiplied. We'd multiply by, if this is radical 5 in the denominator, we'd multiply by radical 5, and then we'd just multiply, and that would be it. But here we have a binomial. So what I'm going to do is get rid of those radicals. And we can get rid of radicals by multiplying by the conjugate. So I'm going to multiply the top and the bottom of this fraction by 1 plus radical 5. When I do the top, I'll have 3 times 1 is 3. 3 times radical 5. Radical 5 times 1 is just radical 5. And radical 5 times radical 5 is 5. That simplifies to 8 plus 4 root 5. That is what is on the top. Then I'm going to multiply the bottom. And if I do this right, hopefully I get just a regular number, a whole number. So let's try this. 1 times 1 is 1. 1 times radical 5 is radical 5. Negative radical 5 times 1 is negative radical 5. And negative radical 5 times positive radical 5 is negative 5. 1 minus 5 is negative 4. And then the 5's cancel each other out. They're 0. So this is all over negative 4. Now I can simplify this and do one more step to do that. 8 over negative 4 is negative 1. And then 4 over 4 cancel out completely. So it's going to be negative 1. And then this is negative radical 5. I made a mistake. 8 over 4 is 2. Just making sure you're paying attention. I'm joking. I'm kind of out of it. Anyway, that is what we'll have there. That's what you're doing on your homework assignment. And again, homework assignment is on page 376, numbers 2 through 44. Sometimes you're adding, subtracting radicals. Sometimes you're multiplying binomials. And sometimes you're just rationalizing the denominator. Have a good weekend, and we'll see everybody on Monday.